Yeah, Chris, please go ahead.
Thank you. I have a question for Alice on the Maestro system, which was a very interesting presentation. Thank you, Alice. I think you alluded at the end of your presentation that in the next step you'll be using real cloud mask fields. And obviously that's going to be very, very different because it's quite common a tile with a little bit of SST in one corner rather than information scattered across the tile in the tests that you've done so far. And I was wondering how you think the technique will cope in that sort of situation and what strategies you'll have to fill in this situation where frontal cloud or other forms of cloud are obscuring continuous parts of the image.
Hi, thanks for that question. Yeah, I completely agree. The previous technique that we've been doing, the random masking, it's not, we're hoping that situations where you had like 90% masking might quasi mimic what we might see in the real world, but I do agree that they are going to be different, and I anticipate that we might have to try different methodologies in order to handle the real cloud covers, because agreed, they're going to be very different and kind of all over the place.
Thank you. I have a small follow-up, if that's allowed, which is you were using a certain size of tile, and of course another issue in going global with this eventually will be that you'll have to, which is probably too large a problem to solve all at once. So again, have you any thoughts about where you'll go on the issue of how to tile up to a global scale?
Yeah, I think we're going to tile based on like one day.
Oh, I see. You'll do the whole
doing,
global.
right,
Yeah.
for one day. Exactly.
Oh, so that's a practical size of problem. That's impressive. Thank you.
Thank you, Chris. So, other questions, Chiara?
Not that I see. Thank you. Try the audience. Okay.
Okay, we take questions from Neeraj first.
Yeah, this is Neeraj. This question is for Emily. Very nice presentation, Emily, and it was quite interesting to see. My question is that basically you used a numerical, high-resolution numerical model for the training data set. So, yeah. Alice, maybe, yeah. So sorry, it's for Alice. Basically, it's regarding the means gap filling of the sea surface temperature in the data set. So I wanted to know that means it is highly dependent. The technique is highly dependent on the accuracy of the model also. Means it should be able to simulate the real world features like the gradients in SST. So unless that is achieved, so the synthetic data means using the synthetic data may not be effective. So can we also means it would have also been better to use large years of satellite observation itself to train as a part of the training data set?
Yeah, definitely. That's something I didn't mention. I was considering whether or not to mention it. But yeah, I think like in terms of like immediate next steps, the first step that I see in like moving this project forward into like making it a more real product is, like I mentioned, to experiment with more Veers tiles as a test set. And then after that, the next step would be to use real cloud mask. And then again, kind of like what you were alluding to, the next step after that is to actually train on real Veers tile. And I'm hoping that we'll get even better results. Again, these are kind of experiments that we need to run to be sure what the outcome is going to be.
Maybe also we can add different noises in the model simulation before using them for training. So that can also help to take into account the satellite errors.
Yeah, very good suggestion. Thank you.
Thank you.
Yeah, Christo, yeah.
Hi, Christo at CSR. So Alice, you are very popular. This is a very interesting talk. And I was also wondering about the training set, and probably following on from the previous question is, well, when you're looking at level 4 data, the horse is already bolted and submeter features are compromised. So if you're starting at that level to train, we might have some issues. So if taking it down perhaps a notch to level 3, single sensor, and then how does it deal with anomalies instead of just having the cloud already masked? If you pepper anomalies, like spurious temperature differences, how do you resolve a continuous expected image like you would expect in a clean VS image?
Yeah, so with that situation, I think with the simulation data, we are pretty fortunate that it's more or less we're not seeing like we're not seeing noise or any crazy anomalies. Definitely a concern with when we're going to be training or testing on real satellite data. That's something that we are expecting. So just something that we'll have to experiment with and see how it'll handle it. Like something that we're anticipating might be an issue is data that was taken during the night or the day. If areas under the clouds would be colder, things like that aren't currently captured in simulated data. So we do anticipate that we'll have some hurdles and some new methodologies. We'll have to come up with new methodologies to overcome that.
Nidant, next.
Just in continuing to this particular question, as you say, and how do you take care of the seasonality and the diurnal behavior of the SST? Because you know, when you take static images for Facebook, it is good because images don't change. But SST has a strong variation in terms of seasonality and diurnal behavior. So, is there anything which you can do in the model to take care of it?
I feel like the answer that sometimes people would give is that more data and will always will make models more generalized, and then kind of like what we were doing in the preliminary experiment that we showed today with all the augmentations. I think more augmentations, including, and then we're also experimenting or starting doing initial research into multi-temporal models. So where we're adding in the time component. So for what I showed you today, it's kind of like stagnant data. There's not really any relation between the tiles. So that's also something that we're looking into.
Thank you. And the second question, if you allow, Thaplial, to Rishi.
That we can continue during the tea time.
Okay.
So, because there are many questions here. So, Chris, so do you want to come in again?
Thank you. I have a question for Chong. It's really the same question after that very nice talk of Hungatunga eruption. I don't think it was really fully answered. The water vapor in the stratosphere obviously influenced the aerosol evolution, as you nicely showed, Chong, but it does decouple in its location and altitude over time, and the elevated stratospheric water vapor is still persisting to some degree even now. And so, have you any plans to actually look at the water vapor impact in isolation rather than in conjunction with aerosol? Because water vapor in the stratosphere doesn't have the same brightness temperature impact as water vapor in the troposphere on average. And so there will be some effect on your NLSST, and I wondered what your plans are for looking at that.
Thank you, Chris. Yes, it's a very good question. As I mentioned, I think basically the water vapor effect and the aerosol effect are connected and interacted together. So it's pretty difficult to, isolate the water vapor effect from the aerosol effect. But yes, the abundant water vapor injected into stratosphere is indeed significant, but actually for the total column water vapor, the increase is pretty small because the amount of the water vapor in stratosphere is just very smaller than the tropospheric water vapor. So, and also we found that the total column water vapor in the matchup database show a reduced tendency in 2022 after the Tonga eruption. So we thought it might be the aerosol effect on the precipitation. So Yes, I think maybe it's not necessary to reprocessing the algorithm, uh, the coefficient, the algorithm coefficients for the modus NLSST retrieval. But yes, it's still necessary to study the water vapor effect. But honestly, I don't have a very clear idea of how to conduct this research. But yeah, it is worth looking at this. And yeah.
Well, I'd like to stay in touch with you about that one, Sean, because I think there are things that you could do, for example, with the radiative transfer modeling to explore this at least.
Yes, yes. I actually I try to use the RTTop like to study the perturbation of the water vapor in stratosphere, but according to the RTTop simulation result, is the SST error introduced by this perturbation is very insignificant. So maybe
Oh,
using LBL RTM or other more accuracy radiative transfer model is necessary. So yeah, it could be done in the future.
thank you.
Thank you.
Thank you. So we can have one or two more quick questions. Dr. Verma.
Yeah. Thank you. I have a question for you, Dr. Jacob. My question is that you described the Copernicus imaging macroradiometer, and you told that SST accuracy, targeted accuracy is 0.
Dr. Verma, can you keep mic close to your mouth?
Yeah, sure, sure. So this is about the CIMR, and you said that SST targeted accuracy is 0.2 degree centigrade. So my question is that what is the accuracy, targeted accuracy for the instrument in terms of the noise equivalent brightness temperature for different channels, and how it is going to affect the retrieval of the SST. Second is what is the uncertainty due to the water vapor and the cloud liquid water that you expect, and also because of the change in emissivity because of the wind speed. So any such studies carried out?
Yes, well, the processes that ESA have made a very long document called mission requirement document.
Okay.
So in that document, there are all the specifications and all the requirements on what should be the target requirement on for different variables.
Okay.
So it's all stated in there, and I don't have all the numbers in on top of my head. But it's I can tell you for SST they stated that, I mean, and that's one of the drivers in terms of the design, that for SST it's 0.2 globally, but 0.3 for the polar ocean, because we know that we have a small sensitivity to the surface temperature and breakaway for colder temperatures. But similar to that, there are also requirements on the CRS concentrations, on the water vapor and so on.
Okay.
So yeah, I can point you and I'll give you the exact numbers for all the different all the variables.
Okay, thank you.
But it's true that it's all coming to the noise and the uncertainties in the instrument, and they have to be very small. I mean, they have to be designed to meet those requirements on the variables.
Okay. So actually, I had another interest of that, whether for all values of the cloud liquid water.
I think we can discuss more
later. Later.
Maybe we can discuss more later during tea time.
For the coffee break.
Yeah, sure. Thank you.
Now, next, one more question from Man Vinayak.
My question is for Alice, and it is related with the application of your Maestro. So my question is whether this technique of gap filling could be used for making the coarser resolution model output to the high resolution model output. Am I audible, Deba?
Alicia.
Yeah. Trying to think. Edwin, since you're on the line too, do you want to take that question? Trying to think if our current implementation could do that.
Suppose if I do have a coarser model output of the SST, and considering that there are gap fills, and suppose if I take the coarser model output, can I use this gap filling method to make it high resolution SST product?
Edwin, you're on mute if you're trying to reply.
I think I guess he can't unmute, but I think conceptually it's possible. Yeah, I think it's conceptually possible. I don't think like the way we currently implement it or the way we're currently do it. I don't know if it would be totally transferable, but conceptually it's possible.
Thank you very much.
Okay,
Pallavi has, I think, a quick question.
Yeah, very quick question for Alice again. Just you showed the comparison with ground truth. I'm just wondering what is the ground truth? What did you consider as a ground truth?
The ground truth was from the simulation. So the simulation is all pretty clean data. So what we did was we just took the simulation data and then we removed patches from the simulation. So we knew what the ground truth was from there.
I think now we will close this session. We had a very fruitful discussion, and we are very pleased to announce that we have our controller space application center, Mr. Vivek Jain, and sir, you are most welcome for this session and for sparing your time to come and attend and grace this meeting. Thank you, sir.